Okay, this is our basic control unit. It is called the Ford Fisher-Oriana resonation device, and it is for testing the cell units to see what the right frequency is for the cell that you're building. Relatively simple. On this side, there's the pulse. It is controlled by oscillator timers. These resistors here change the oscillator timer frequency. These capacitors here change the pulse rate of that frequency. This side controls the actual frequency of it, and these capacitors change the frequency load. Now, the 555 timers are well known. There is several different types of calculators to figure out what your load is. All you need to do is figure out what your frequency is that gets your best resonation, and then send that to me, and I will send you a box that will do that job. It is self-adjusting. It has a fuse system here at the top that is simply 3 10-amp fuses. Each one can power a different cell, so you can test a total of 3. Amp gauge, which goes up to 30 amps. You should not need more than that, because even the bus bar fuse, this one, is only 30 amps. Okay? This is actually the gauge power bar, bus bar, and allows us to read on the ground side what's going on with the amps, how many amps are actually traveling through the system. It's a good system because it allows us to have a positive read of everything that's going through the box without any interference from the box. Okay. Now I've hooked up a IC motor to the system, and it's right here. We'll plug into the circuit. Now, the circuit itself, got to disconnect it for a moment because I've added a diode. The diode is here. It is set up so current will not pass from the positive side to the negative, but will pass from the negative to the positive. The reason is because we're using these water cells as a capacitor, and we want to make sure that it keeps the current in the system in the correct place. But it is used as a capacitor. Okay, plugs into our standard connector, our Nomex, and it works fairly well. It plugs in. Each one is able to handle 20 amps, so you should not burn these systems up. All right, now give me just a second. All right, so I've hooked up the IC motor. I'm getting ready to turn the switch on. You will notice that when I turn the switch on, this LED, which shows power to the board, will go on, and these LEDs, which show ground through the MOSFET, will go on. The reason they show ground through the MOSFET is it shows that each MOSFET is functioning. If the light goes out, the MOSFET's dead. Okay. If this fails, the board is dead. Turn it on. Now, if you'll notice, these lights flicker at this low frequency. And you hear the sound from the motor. It's making that noise because it's pulsing. Okay? So it doesn't just have a frequency situation. It is a pulsed frequency. And we're going to change the pulse. Notice the motor changed. LEDs became solid. And that's because we went up in one capacitor from the 42 microfarad to the 4.7 microfarad. Now we're going to go up to the 2.2 and the 4.7. We're once again pulsing. Okay. Change the frequency again. Okay. Now we're at the 1 microfarad. Now this is the 2.2 and the 1. Okay. Now we're up to the 0.1. Okay. This one is 0.1 and a 0.2.2, and this is a 0.2.2. So this is the frequency that we run. Okay, that's your pulsar. Now that we change the frequency by changing this knob and this knob, we change the overall frequency that we're working with. Okay. Now this side does the same thing in the same kind of sequence. Has 8 positions also. It changes the frequency in hertz of the water. So first you change the pulse rate to get some action out of the water, and after you have the action, then you change the frequency to get the greatest amount. Okay, this goes from 1 kilo ohm to 6 kilo ohms on these, 1 kilo ohm to 10 kilo ohms on these. The LEDs will show that there's power to that circuit, a ground to that circuit, and the circuit's working. That little electric motor doesn't do much, but it does read on the gauge. And expect probably somewhere between 6 and 8 kilo ohms or ohms resistance through the system. With each cell, you should be able to run anywhere between 5 to 8 amps through each cell. So gave you 30 amps, you should be able to work with that and make the system work. Now, the only other thing to worry about is the connections, the red wire positive, blue wire negative, and there is a fused circuit here with 30 amps that will hopefully prevent any failures of the system.